Hello everyone, welcome on our regular core protocol sync. We'll talk today about core protocol and what was happening interesting around that during last few weeks. Lucian, you haven't been on the previous call. Let's maybe start with you.
Okay, sure. Okay, let me share my screen. Okay, so you could see my screen now?
Yes.
Okay, great. So since last call, I was able to finish this PR. The last four commits are new. It's mainly like to address the comments, like we store the execution receipts like by the hash, not the block number. And in order to do that, we need to check the block number, use another storage. So yeah. And the other things is, okay, this one is like to fix the microtrade like problems. This one is refactoring, and this one is another fix. Okay, so the main point of these four commits are to store the execution receipts by block hash instead of the block number. And some details can be seen in the commit messages. Yeah, that's everything for this PR, I believe. Any comments, questions?
Are there any other PRs after this, Lucian?
No PRs.
Okay.
But this post, no other PRs.
Okay. Could you summarize the current status of the, like where it's at in terms of the implementation features right now?
You mean this PR?
Yeah. So like how far are we right now in terms of like the actual decoupled execution? Like what point does this get us to?
Actually, this PR is mainly like to store the locally produced execution receipt for a while, so that it can like compare the external receipts received from the network. That's everything for this PR. After this PR, like we, in theory, like it should work. Like once we detect an invalid like receipt from the network, we can submit a fraud proof. Like if the proof generation is ready. Yeah. So basically, after this PR plus the fraud proof generation, the main workflow should be done. Yeah. Like the happy path.
Well, the happy path is working, but now we're working on the unhappy path, which is fraud detection, fraud detection, fraud proof generation.
Okay. Oh yeah, yeah.
And then so what is it? You have to detect the fraud, and you have to generate the fraud proof, and you have to validate the fraud proof, right? Those are the three steps.
Yeah.
So now we can detect the fraud, or we should be able to detect the fraud, but we haven't actually. We don't have a test framework yet to verify this.
Yes. With this PR, we can check the external receipt so that we can submit for the proof. Yeah.
Okay. Does that make sense to everybody?
Yeah, so will the next step be the test framework or something else?
Okay, that depends. Like if the extrinsic execution proof like can make some progress, this will be the top priority. And I have found some problems, like the state, like between the sync node and the executor authority node, like doesn't match. So I need to fix that. But it probably will be fixed with the test framework, but it's not guaranteed. So the extrinsic execution proof, the test framework, they can be done in parallel or will be worked in parallel, depending like which will make some progress faster.
Okay, so you're going to write both of them in parallel, and it's just kind of discovery of where you find bugs. Like you don't really know what you don't know.
Yes. So like for example, like the current latest state for the extrinsic execution proof is that I was like able to generate the execution proof like using the approach used by like a Substrate light client, but I'm not sure like if that approach really works like in theory. I need to verify, and during the verification, like unlikely they doesn't match. So the Bastien from Petty is helping out, I believe. So
what is
at the meantime,
sorry, go ahead.
So at the meantime, I'm looking into the like the issues found like in series, like the sync node and the authority node has a different state like after the computation. I'm looking into this issue.
So what is an execution proof? Can you show us like concretely what that means?
Okay. So currently the fraud proof like used in the parachain, we can call it a block execution proof, right? It detects the entire block execution, like whether it's right or like is valid or invalid, right? The validator of relay chain like will like detect if every single like a parachain block, the state transition of each like parachain block is valid, right? Which is called like block execution proof. And if say like that is called block execution proof, what we want to do is actually the extrinsic execution proof. When we detect like any like state transition of an invalid like extrinsic, so we need to like build a proof on top of that invalid like extrinsic state transition. So it's just a terminology. Still, what we like discussed before.
Okay. And you're just reusing the framework that Substrate has for block execution proofs, but just scoping it to a single transaction?
That was the original plan, but it doesn't work that way due to the overlay. So result to another approach, which is Substrate was like a Substrate plan to use that approach for the Substrate client, which is to like prove an execution for a method and like the code data. Yeah, it's currently like the same thing, kind of. But the like the method, the approach used for the Substrate light client doesn't like have to like to be mastered with the overlay, I believe. So that's what I'm trying right now. It should like to able generate the proof for each extrinsic. The problem is if this proof is correct. That's what I'm like doing right now to verify if this proof is really what we want. But still have some issues with that.
Yeah, this is kind of similar to SPV light client, where like you have just headers, you need to prove that there is something there and it was actually executed correctly. So they have like a way to make this like additional proof. There was actually one more. There was Jeff Burgess from Web3 Foundation joining the thread, and he was asking more details about why we are trying to do fraud proofs about one transaction instead of the whole block. That they were already exploring that in the Polkadot, and they had some challenges with that. So I had to like do some explanation, and maybe he'll have time to read our white paper to like have shared terminology, because I feel like I'm re-explaining it many times over and over again, even in this thread, like what we are actually doing and why. And he said that like the way they do it already doesn't really match very well with ZK UTXOs. And they might consider to have some changes in Substrate to enable those use cases. So maybe if they understand better what we are trying to achieve, they will have something in Substrate that will allow that to happen more easily, I guess. Yeah, this discussion is like over a week long. All right, no, it's about a week long.
Yeah, with Jeff, discussions kind of go way off topic and can be kind of pointless. We've done this before in the whatever element chat a couple times already. So just don't be careful.
Okay, so that is everything on my side.
So what is the test case that you're using right now, Licheng?
For this execution proof?
Yeah.
So that is what I wanted to do. I actually like use two methods to generate this proof. And I wanted to compare if they produce the identical result. This one is kind of the to mimic the block execution proof. Like it's not correct, but it's enough to generate the proof for the first extrinsic. So I would like to use that approach to generate the proof for the first extrinsic. The second approach, like I'm using right now, is able to like generate a proof for any extrinsic in the block. I wanted to compare them if those two proofs are the same. If they are the same, I believe, yeah, it works. So,
but what is the actual execution that you're testing? Like, are you sending money from Alice to Bob or running a smart contract?
Yes. We can quickly take this. I'm just like use one simple transaction transfer. Yes.
Okay. And how are do you have a test framework, or are you just writing these like one-off tests, like integration tests?
It's more like a unit test. I haven't be able to mock two nodes. Like one is sorting nodes, one is the sync node, and let them run and connect. That is what I would like to achieve with the test framework later. This is still the unit test.
Okay. So all this is just like theoretical right now that this code works.
It should work, but yeah, you have.
It should work. Yes.
Yeah, you have to verify like it really works. I can generate the proof, but I can't guarantee it's correct. You know, I'm not
Okay.
sure if this like would. Yeah. Yeah.
But you're already getting different state roots from the sync node from the local farmer and the
Yes.
executor.
Yes, I already get the data, but just the data, I'm not sure if it's correct. Yeah, I basically have got everything. If you are talking about the data, I can generate them. Yeah.
Okay. It just feels like you're doing like a lot of different things in parallel here, and we might need to just step back and try to figure out like a test framework so that we can actually, because we could make a lot of progress on code that's not actually working. And if we wait to have like a framework at the end to sort of sort all this out, it feels like it might be more productive
yes.
to have a better way to test this first.
Yes, but I haven't like quickly set up a proper test framework. That's what I'm thinking recently.
Yeah.
Yes.
Yeah, we have one in the main subspace node implementation, but that one also needs to go away. We need to have like a normal framework because that one was copied from Substrate and they want to get rid of it as well. And doesn't support transactions.
You know, yeah, I checked the test framework of Cumulus, of the original Cumulus. Like the Cumulus was using the polka dot like test framework. So yeah, just needed some time.
I think we could use like Monk or something like that as a way to just have a defined way of spinning up two nodes or two mini networks and running some
yes
tests like that, the more programmatically.
Yeah. If I can't like borrow the entire framework, I'll choose this way to like make a minimal example to spin up two nodes. Yeah.
Well, hopefully you don't have to do it because that's kind of heavyweight and brute force way to do it. You should be able to like spin up two nodes in memory and connect them without actual networking.
Yeah, I'm just like would like to find a like proper way to do that.
Okay.
Yeah.
So what is your priority now out of all that stuff that you're working on? What do you think it should be?
So first thing, the extrinsic like proof. The second thing, I believe, will be the test framework and fix the issue, like the state mismatches between the sync node and the assorting node. After that, we continue the like new features.
Okay. So I'm just trying to get an idea for the timeline here. So you've got to devise a test framework. You've got to debug this issue, fix the extrinsic proof, then generate the fraud proof, then verify the fraud proof. So it sounds like that's like 4 to 6 weeks.
That depends, I would say. You know, never, some unknown problems.
Mm-hmm. Okay. Do you think you can have a test framework by the end of this week?
Hopefully, I believe.
Okay. I mean, that seems like less of a research and development. Like that's not like a theoretical question. That's just kind of like a implementation design question.
Kind of. Like you need to figure out what's the best way or the proper way to starting like the test framework.
Yeah. And that feels like a priority to me, that would make a lot of this stuff move faster if you had a proper way to test this.
Yeah. So the bug the issue I'm debugging right now, like I hope it will be fixed with the test framework together.
Okay. Any more thoughts, Nazar?
No, I was generally following. I just need a bit more time to actually review the new commits. Hopefully we can merge it.
Okay. Yeah, and on the testnet side of things, Lu Cheng, so we're planning to launch, we're kind of in like Gemini 0 right now. We just haven't announced it for the testnet, which is non-incentivized. But when we get to incentivized, we're planning to have like a single trusted executor on the network, or like an executor that we run, and then eventually upgrade it to be like other people running executors on the testnet. So this will converge with like FarmNet, so it'll be like farm and execution net. Hopefully by the time that you have this 4 to 6 weeks or whatever, that you have this full path worked out.
Okay, so that will include the further proof part, right?
Yeah. But just I mean, no functionality aside from really balance transfers or like storage puts. Nothing, no smart contracts or anything like that.
Okay.
But still, like the kaput execution node and regular node, they are kind of independent right now. It says that like coins are not shared between them. Like you cannot like teleport them between those like chains essentially. So this will be another gap to bridge before it's actually usable. Like it can run, but it doesn't really do anything useful yet. That will be a little bit of a challenge.
Yeah, for sure.
All right. Let's maybe jump to Ivan.
Sure, yeah. For the last week, I was working on after we finishing the Uniswap B2 smart contracts in the substrate. I was reading the white papers related to the storage side of the protocol. Yeah, I was reviewing the attacks on the proof of space and BRFs. So also I finished right now the paper related to the DHT related to academia. So moving on to the academia. Yeah. Also, I plan to read the white paper about Fly client and then move on to the executions part of the contract. So, not the contract, but the white paper, the kaput execution and everything. So yeah, that's it from my side.
Okay, any questions you have, or I don't know, issues you see from what you read so far? Or
I
does
guess,
it make perfect sense to you?
Yeah, it does make sense. Yeah, I mean, I just tried to watch like some of the videos about the academia at first. Yeah, also I heard about it before. So yeah, everything like makes sense for now so far. Yeah, I guess there will be some issues with the academia. Yeah, also thanks for the links which you sent about the BitTorrent. Yeah, that was really helpful.
Yeah, Escademia, it's not like a real separate DHT. It's just like hardening methods, like different ideas how you can make Academia more secure, because there are some challenges in it if you are using it like out of the box. And BitTorrent is useful because that is probably the biggest production live DHT in the world. It's just called mainline DHT. That's why, and it's really quite simple the way it's designed to work, and it actually has proven itself to be somewhat reliable. So that's why it's useful to take a look at that. And this is basically what most of the other protocols mimic. If you look at the implementation of Kademlia in Leap peer-to-peer, it closely follows what Kademlia, what the implementation of Kademlia is in BitTorrent. Slightly different methods, but like general, basically the same naming conventions and stuff. So
thanks for that. Yeah.
Yeah, and I just sent you an invite for us to do another onboarding discussion after the all hands on Friday, everyone.
Sure, yeah, I will schedule it, yeah, just after the meeting.
okay. I don't think I have questions about that. Ozgan, is there anything you want to share on your side? You're muted.
I think I'm not now. Okay, thank you. So I started implementing the plotting progress tracking, and it's working on the library side. Today I just figured out the library side, and tomorrow I will plug this into the desktop application. So it's just using the event handlers like you did, Nazar. And I tested this in here in some test. I will remove this. It was just a proof of concept. So it printed out the pieces plotted by the plotter, which is good news. So I think this is ready to use in the desktop app. Other than that, we had changed, fixed the bug on the, again, farmer library side. Do you want me to cover this change or should we skip it?
Yeah, let's cover briefly.
Okay. So basically the error was happening in here. This happened after we introduced the codec crate, and when there is not enough piece here, this division was making it 0, and then we multiply it back, it was again 0. So we were basically sending 0 pieces to GPU, and it was creating an error allocating for 0 pieces. This is fixed by this guard, and other than that, not so many different changes. This was the main bug fix. There are some other small things, but we don't need to cover that. One more thing important is when the GPU creates any other error, we are making the available. Okay. Okay. When any error happens, we are making this false. So there could be some other error that we didn't think of yet, but it's now error safe. So when an error happens, we are making this false, and then CPU will take over from where GPU left off. So now I think we are in good hands. And also, there is one more change in the slot side.
I had a question about this. I was
Yeah,
going
sure,
about this bug first. This is for the existing CUDA codec that we had, or this is the new unified codec that Supernational worked on?
New unified codec is not merged.
Yeah.
Okay.
Mhm.
Aren't we going to replace this with that codec, or are we going to be using both differently?
We'll probably replace it eventually.
Yeah.
Okay. Okay. I'm just wondering if we should spend that much more time optimizing or fixing bugs in this if we're just going to be replacing it soon.
Well, the first question is when this will actually be, and the second one is that it already causes problems for Todd and Ozgun when they try to run it on Windows. And it actually detects and has working good implementation. So like this was an obvious bug which needs to be fixed.
Okay. But as soon as we have the code from Supranational, we're just gonna like remove all this from the library and just use the unified
No,
kernel,
we'll
right?
just replace call to CUDA with call to OpenCL. The rest is still there.
Well, that's what I mean. The call to CUDA will be, there won't be a call to CUDA anymore. It'll just be OpenCL.
Right, but the other code will still be there, like the scaffolding.
Right. Right. Okay.
I had the same
Okay.
question.
I guess I'm just trying to say like we shouldn't spend too much time. Like if it's broken, I get it, but we just shouldn't spend like too much time on legacy code that we're just going to end up replacing soon, anyways.
Yeah, I had the same question. That's why I asked Nazar, like, when are we going to merge the supranational PR? Because if it's soon, then this time will go in waste. But actually, it's not that, not as Nazar explained. So it was a good investment, and we are not diving in so deep, so it's fine. It took 1 or 2 days.
Okay. What is the status with Supranational right now?
They haven't replied back, as far as I know. So they were going to answer some of my questions, and I haven't heard from them.
Yeah, there was no activity that is visible to us.
Should we ping them?
When was the last time when did we ask the question?
Ooh, we had a call with them. It was
on the meeting.
2 weeks ago.
Let me open my calendar. I don't know.
I think so. Yeah,
It
was Thursday 2 weeks
we
ago.
definitely should. If we're not hearing back within like a week, we should reach back out to them so we can close the loop on
It's
this.
nearly 2 weeks.
Because I think we've already passed the milestone delivery date that was expected.
Okay, who should do it?
Hoskin, can you? I mean, these are your questions, right? So can you just follow up and just, I mean, if you don't hear back in a few days, ask again. If you don't get a reply, let me know. I'll reach out to Kelly. They're probably just busy or lost track of it. Okay, so once we have that code from them, then what are the next steps? Is it like we're asking them to refactor things, or we just have questions about the implementation?
We have questions about implementation. We have some things which they need to fix. And then there is still quite some work for me to just refactor it and make it actually safe and not pretend to be safe, and some documentation and just make it into the shape that we can merge it. So that will be like a few days of work after that.
And then at that point, Oskin will be able to use that to implement it in the farmer library.
I think so.
Yeah, either Oskan or me should work either way. I think the API will be kind of similar to what we have right now. It will be slightly different, but it will be similar enough, I think.
I agree.
Okay. Yeah, let's follow up on that, Oskin, and then if you can let me know.
Sure.
Let us know what you hear back.
And this was fixing a potential bug in slots 256 and 189. So after Supranational's code is integrated, this will be obsolete. So maybe I shouldn't dive into that because this will be gone either way. But right now, it's making it more safe for the current GPU plotter. Do you want me to explain what's happening here?
Nope.
Okay.
I think it's fine.
Okay. Other questions to Ozgun about all of this?
What are your next steps, Oskin, or what are your priorities this week for the library, farmer library?
Yeah, the library is ready so that I will plug this into Subspace desktop app. And after that, I don't have anything specific, so I was planning to clear some items from the backlog.
What the backlog for the farmer library, you mean?
Yeah.
What is it in the backlog right now? And how are you thinking about priorities for that?
On my side, I think we can make the commitments simpler. That's all in my list.
What do you mean by simpler?
For fixing
Implementation refactoring.
Yeah. So after fixing the bug with Nazar, we fixed it, but it kind of got more complicated, and I think there's a more elegant solution to that. I will implement that after finishing the priority.
Can you? Sorry, I'm still lost. Can you maybe Nazar? Can you explain what you're thinking there?
Yeah. So the way the code is organized, how we maintain the list of databases with commitments, like how we track which is the old one, which is the upcoming one, how we replace them, how we delete them. All of that is kind of convoluted, and there is an opportunity to make it simpler and more easily understandable. I actually had like a few commits as we were coding with Ozgun that were like simplifying some things and changing some things. In the end, I found that there is like a simple solution to the root problem, and we just pushed one commit from that. But there is like another branch which has a few things prepared, and Ozgun had some other thoughts how to like change it, so it's like easier to follow and generally like better implementation. Doesn't change the essence of what's been done, but there are different ways to implement the same thing, and the way it's currently done, it's not the best one. We all agree on that. So
yeah, same functionality with simpler code. That's all.
Yeah.
Okay, that makes more sense. Thank you. Yeah, I still think that we're gonna get rid of this like monolithic switchover from one commitment database to another and have a more like progressive incremental switchover. But that's like a protocol design question that we have to figure out first. So I think it might not be worth our time to like optimize an implementation that we're just going to abandon, or like a pattern that we're probably just going to abandon. I mean, in terms of like priorities, that's probably not as high on the list.
I don't understand something about that. Like, even if we are going to make the change gradually, won't we delete and insert some new databases? So the implementation shouldn't change that much. At some time, one of the databases will be old. We will delete them, and at some time we will gradually start to insert a new database. So we still have to deal with logs, databases.
I mean, at a very high level, yes, but without really being able to specify the protocol, it's hard to make any kind of concrete, thoughts about how that would actually work. So,
yeah, I tend to agree that the way it will look like in that case will probably be quite different from the way it looks right now.
Okay.
It's more like I guess an exercise for us going to try to see if there is something can be done significantly better.
Nazar, is there anything that you see on the farmer roadmap, like separate from like networking or DHT stuff, but just more internal to the mechanics of the plotting and the auditing process?
I don't see any burning problems.
Okay. One thing that I've been thinking about is a way to measure or like benchmark more clearly plotting progress and like the overhead associated with running a farmer or running a node, so that we actually know like how much disk space does this occupy, how much of it is in the BST, like some sort of like metrics or report or something like that. Like how long does it take to do the recommitments? Like there's just a bunch of stuff here that we just kind of like very hand wavy about right now.
So general monitoring. So you
Yeah,
can
I
have
mean,
like
like
charts about like current plot size, current BC size, which is active, which is inactive, how many like solutions we found, and that kind of thing.
yeah, that's part of it. Another part is like, I mean, we need to get eventually to a point where we don't even know like what the difference is between putting the BST on like an HDD versus an SSD, like what the performance difference is in terms of like the time to do the reads, or if that just causes the HDD just to spin continuously, you know, for forever, because of that. Which otherwise, like if we had the BST on an SSD and the HDD just had the
well, if it's all every second, then it will not be able to stop. That's for sure. Like it will not be able to park for any meaningful amount of time. I believe like mobile SSD hard drives, they might be like half a second time after last access that they will park. But for this case, you'll probably want to disable that feature. Otherwise, you'll just park and park, and that will just destroy your hard drive. But that's only mobile devices. On desktop, it's usually like several seconds at least. So I don't think it will stop. It will just spin around, but that usually doesn't take out of energy. Like spin up usually is like, you know, like in motor, it's like a spike of current. So it
Right.
shouldn't be that bad.
Right. Yeah, I mean, it shouldn't. That's the point. Like we've kind of
Well,
not
it
really
definitely will
100%.
not. Like I can guarantee that because there's no
Okay.
other way.
Right, but I guess there's just a lot we don't know. Like kind of with some of the feedback we got from the guys at A16Z about just performance benchmarking and understanding how this actually works, how it works across hardware, different types of drives, different types of machines. Can we get it to work? Does it actually work on a Raspberry Pi? Like these kind of things. I think a lot of it comes down to this implementation of the farmer and the benching of that. So that's something I see as like a big something we've got to really set up some framework for, or some way to capture that, and then just some way to monitor that, especially now that we've got 12 people, 13 people on the test net. We're supposed to have 25 by the end of this week. Probably by the end of the month, we might have 50 people on the test net. So there's a lot of data that we can get here. I mean, we make it voluntary for people to provide this data, but or that we can just run ourselves from benches as well. There's ways we can incentivize people to do this, but we really need to kind of collect this information and learn from it, and make sure that we can feed this back into the design. So right now we're just it works, right? Obviously it works, but we really don't know a lot about the performance characteristics of all this stuff. And if we're going to have it on 10 million computers across the world, we should really know about what the performance impact of it is.
Okay, so this is basically benches for Subspace Farmer library.
Yeah.
Like the actual combination of everything and the way we use it.
Yeah. So plotting is something we have, I mean, more sort of like manual. We've done benches of this before, but we need a way to like log this, and then also like the overhead of just the continuous challenge response audit of that. That's the thing that is really the big unknown right now.
Okay, that's fair.
I think there's also a lot of, not a lot, but there might be some room for optimization around like some kind of a tiered commitments database, where it's like maybe the head of the tree is in RAM, maybe the mid part of the tree is in the SSD, or part of it's even on disk. There's like these advanced, databases that do this already. there might be like kind of like parity DB, which is like a replacement for RocksDB that's really well suited to like a flat key value store. There's probably like an efficient binary search tree, which is which can be like multi-tiered across your potential disk types that you could have, that could be much more efficient, much faster, lower overhead. I don't know. Just something to think about.
Yeah, I believe RocksDB already has some caches. And this is one of the reasons why ParityDB exists. They want to remove those caches because for the use cases of the blockchain, they just do a lot of random accesses, and it doesn't help to have caches, just waste RAM. So they deliberately removed any caching support on this level and say that you need to cache it on the higher level when you have some meaningful structure to it. In our case, I think RocksDB should build some kind of index for the keys and should probably have some portion of that in RAM. Would be nice to figure out if that is actually the case. It does consume some RAM, like there is some percentage of the database size which usually takes RAM, but I don't know the details on that.
Yeah, there's like this article I remember we looked at a couple of years ago, and we were first looking at RocksDB for this range search, and there was this whole like blog post on how like fine-tuning like the parameters for how you set up RocksDB can like dramatically change the performance characteristics of this. So yeah, I agree. There's probably like some settings that we may or may not have enabled that might significantly alter the performance characteristics here.
Yeah, definitely. Okay, let me share the screen on my side. What I was coding. Should be this one. All right, so this is the merged initial networking implementation that is custom built on top of the peer-to-peer. I will just show you the usage example and explain a little bit how and why. So the way it works is the following. We have some configuration. We can define where to listen, where the bootstrap nodes are and stuff like that. We create a pair of, basically the node itself is like a public data structure which you can call methods on and you can clone. And this is the runner, which is kind of like future that you need to drive forward for the networking to work. So we take this future and we just run it in the background. On the node itself, you can subscribe to events. Here we are just trying to find the first address where it listens, send over the channel, and then we in the second node, we'll just wait for the first address to be announced, and we can use that as a bootstrap node to connect them together. And then we can do the query for some value. So the query actually uses the code path for the Kademlia DHT. There is an implementation in the peer-to-peer Kademlia for putting and getting values. However, we kind of not really using that in a way it was supposed to be used. Those values should be put on from one node to another. So like you take the you make a query to find the closest nodes to the target, to the key that you want to put, and then you just issue a put query basically, and those nodes will supposedly store that in their memory or other implementation of the record store, they call it. But then there is no built-in way to like verify whether those keys make any sense. You can like evict those keys. And in our case, we know deterministically that if you are in that range of keys, then you should store particular piece set, right? So we have that implicitly. So basically what I did instead is I wrote a custom implementation of the record store, which ignores every put possible, both for providers, which is their way to announce that you have a key, or announce the other nodes which have a key, or just puts. So it basically ignores both. And for gets, instead of just having in-memory implementation, it actually uses this value getter, which you can provide. And it will call this function with the key for you to return anything you want. So this implementation, just for demo purposes, I'm taking the key and reversing the contents. And then when I'm printing it here, it will print 3, 2, 1, just like a demo. So the idea here is that we will be using this, and we will be reaching out to the RocksDB database, which has mapping for objects, let's say, and we'll be able to retrieve the object and return that, while otherwise using the Kademlia. This is the very like short-term solution. I feel like the Kademlia implementation that they have is both too much and too little for what we want to do. It is too much because it has key value puts and provider puts and gets, which we don't use either of them. Our keys are either implicit or content addressable. And if you do gets, for instance, it will like one of the parameters is the key and the other one is quorum. It will basically say how many nodes you should query and return like the aggregate result, like how many instances of the value you have. In then you need to decide like which of those instances of value are actually correct values. However, in practice, if you're talking about something like mainline DHT, it's content addressable. So as soon as you have at least one value which hashes to the key, you already can stop the query. You don't need to like bother other nodes. And there is no like built-in notion in Kademlia implementation in libpeer-to-peer to actually prevent this like further search procedure to like terminate it earlier. So I feel like we just need the base like Kademlia itself and not key value feature of the implementation. And we need to implement like the lookup ourselves. So this is the first like step to just use whatever they have, all the routines for like finding closest nodes and then issue them query to get something, they reply or not reply, like all of that. But eventually I feel like we will definitely have this like wrapper behavior, or maybe even like simplified Kademlia. I'm just trying to discuss with folks from libpeer-to-peer what they think about this. Maybe there is even like a way to have like micro Kademlia implementation that doesn't have this baggage of extra features. Or maybe there is a potential for Kademlia implementation to have custom queries. So you can provide this like logic. As soon as you have a value which hashes to the key, you can stop querying further and stuff like that. So this is very much like the first step towards that goal. But this should be sufficient for farmers to form a network. And if some farmer doesn't have a piece, they can request it from another node. The way this actually works, like if you have the value, it will be returned immediately, basically synchronously. So it's not like we are going into the network if you already have the key. So you can just use this API as a generic way to get values, whether it's local or remote. I think initially I will implement that in the farmer side. Once it's more mature, we can try to use it in the node to, let's say, implement compact proof of replication. So when they have a piece index, we can just reach out to the network and get the whole piece. But whether it will be implemented that way or just use gossip, which is not implemented here yet, to broadcast the block itself with the piece, I don't know. We'll see. So this is the very brief explanation of what this is. This is just an example application to test the library while I'm developing. It's not integrated anywhere, but I'm fairly certain it works the way it's supposed to work because of that application. Yeah, this is what the record store looks like. We just have a getter recall and everything else is ignored.
Can you go through the keys one more time? What are the keys in this construct here?
What do you mean?
What are the keys on the DHT? Like, what are the objects being stored across this network?
That's the problem. Like, it can be anything. There is no structure.
But what do you have in mind? I guess that's
right.
Now.
It will probably be multi-hashes, the way it will interact over the network, and then or not even like it probably will be. So we have a namespace for multi-codec for our like.
Sorry, I'm not talking about the implementation. I mean, what is the from in plain English? What are we doing to get off of this network? Is it node ID, addresses? Is it records? Is it topics? Could be anything. Like what problem is this solving? I just you were going really into the low level details here, but it wasn't really clear what this is doing maybe to other people.
So initially, it is a way to get pieces from the network as a whole. Right now, we are storing everything on every node. Once we have partial replicas, we need to have a way to find pieces that we don't own physically. So this is the first use case.
Okay, so when you're saying that you don't actually publish the keys, so what you're publishing right now is just
nothing.
Well, what about the well, I guess we don't, because we don't need the peers. The peers are already in the routing table. So that's
you're just
basically
doing like random lookups for keys and just populate routing table, and that's all you need from Kademlia so far.
Okay. So basically, as a new farmer, I join the network. I announce, hey, I'm live. I populate some other routing tables of some other nodes on the network, some K buckets. And then when they want to get a piece, they just basically use the routing table as a way to find the closest peer to the piece, connect to that peer, I guess under the hood, connect to that peer, and then ask that peer if they have the piece or not, because they should.
Yeah.
Okay.
And you don't need like explicit announcements that I have this piece, because we know that they should.
Right.
Or someone else close to them will have it.
Okay. And what about, is there anything right now for topics like we were talking about with like networking, like shard, bootstrap nodes or something like that, or list of nodes on a shard?
Not yet.
Yeah, okay. And there was something else that we were going to put in here too, I thought.
Well, object IDs, we need to expose them over this network as well.
Oh,
like
right.
Mapping from object ID to where it's actually in the history.
Right. But that was, weren't we going to do that by having nodes store the object IDs, which were closest, the mappings, which were closest to their node ID as well, so you can implicitly resolve those?
Right.
Okay.
It's just a different beast because it's not really like content addressable. It's like a separate thing to everything else. So worth mentioning.
Okay. So probably the only actual keys that we'll have on the network will just be the shard networking routing layer, or like the subnet routing right now. The only mutable keys are like temporary keys that we'll have.
Yeah, they're kind of similar to providers. So in Kademlia implementation in libpeer-to-peer, like in the specification, they have a notion of content providers where you can say that for this key, I know these peers that have it. And those peers can like register themselves that I have this, please put me into the like list of peers for that key.
Right.
The problem is that anyone can announce anything. So this is a denial of service vector, potentially. And also it doesn't scale super well in the sense that when you are inserting someone, you're inserting them into the very like narrow, like K or N number of peers around the key only. And then everyone who will reach out, they will reach out to those peers. So I had like a rough idea of how to make it more scalable when you get as one of those N peers many requests, you'll just try to put the same content into wider scope of the network, like around your peers. When they receive a lot of requests, they will like also put it into more peers. So you'll basically spread the information from the key target to the sides of the ring, such that when other peers do recursive queries to find peers closer to the target, they will find someone with the value sooner and then they will not like overload the peers that are very close to the key. But there are a lot of like game theory kind of challenges here to make it not susceptible to denial of service attacks. And unfortunately, the peer-to-peer itself doesn't have a lot of very good solutions for those kinds of problems.
Okay, so it sounds like you're discussing kind of the problem of the traditional DHT that like a sloppy DHT solves. Kind of like what Cord gets out of the beginning of that paper. Or Coral, I mean, not Cord. The Coral DSHT. I mean, not the concentric rings, but just the idea of how the how you maintain the list of peers so that it doesn't just flood or create these hotspots.
Can be something like that, but in their case, it was more for like optimizing the latency, I believe, like physical latency in the real world.
Well, that was the concentric rings of whatever, like based on ping time for the nodes. But there's a more generic problem of just like the more people that request, the more popular an item, the more people have it, like the more people keep publishing it, and then everybody, you know, you get these like really big arrays of basically who has the object, and I don't remember exactly how they do it.
I probably need to reread that. It was like a few years ago. Last time I looked at it.
Yeah,
I made a note for myself. Okay.
Because like standard Kademlia has this problem that you're describing. Like you just read the Kademlia white paper, and S Kademlia doesn't solve this problem. It just solves the denial of service attack problems. But there's this other problem of like just kind of actual scalability and not getting these hotspots, which is what the sloppy hash table solves, which is one element of Coral. But then the other element of Coral is like how do you get better latency with these like concentric rings. So
yeah.
Okay. Do you think that we could have it so that we could expose an API in this DHT eventually that was just generic publishing, like something like how anybody can use the BitTorrent DHT to publish whatever content they want, that people could use like as a
generic keyword store?
Yeah, almost like that 44, but maybe not that specific. But like, yeah, just they could just use it to put whatever data they want. Is like, oh, I mean, I guess that's kind of like what IPFS does already.
So I don't think so, at least not in the moment. Like my biggest dream is that we'll stop having different DHTs. And like IPFS, DHT, and the same technology, but for like substrate-based chains for all of them separately, and Subspace, like they will all converge into the same network, but they will have an efficient way to like layer them into like different namespaces while still helping each other in terms of connectivity. Because right now, if you have any like modifications or protocol-specific conventions, like in this case, we are saying that these keys should be like contract addressable, but in other networks there might not be such a requirement, or they use different hash functions. So when you put a key, they will reject. This is why in Substrate, where you have, let's say, a relay chain and a parachain and other parachain, all of them will use different prefixes for their Kademlia. They're using the same implementation, but they're in different namespaces, so they don't overlap. It's like a physical different protocol, even though everything else is exactly the same. So my goal, like my hope, is that at some point we will finally converge them together. Otherwise, we're just building these like islands, which are disconnected. So this is like the first attempt to have at least generic networking for all of the shards that we have, and not like multiple networks for all of the shards. Maybe the further evolution of Flip peer-to-peer and specs will actually enable that use case. I believe there was a problem already when some of the networks were merged into the IPFS network, and that was causing problems. I believe that happened already. Yeah. But I don't think it will be something that is feasible like within the next few months.
Sure. So you're talking about almost like a meta DHT, or like BitTorrent, IPFS, Subspace, and everybody
Yeah,
just
like-
kind of all
like-
using one standard network.
Make mainline DHT or IPFS DHT like de facto standard that everyone joins.
Yeah.
And can discover like some of the nodes on that DHT which speak the exact protocol that they care about. Like they know how to speak Polkadot protocol.
Sounds like a Subspace meta service, MetaNet. Okay, interesting. Cool. All right. Thanks, Nazar. That's all the questions I had.
Okay, any other questions? We are a little bit over time already. So I guess we'll wrap it up for this week. Thanks everyone on YouTube for watching. We'll see you in 7 days with the new Core Protocol sync. Bye.